Now, let's talk about the derivative at a point. So far, we've been talking about secant lines and tangent lines. Now, we are ready to define the derivative. The derivative of function f at a is written as f prime of a and is defined as a limit. F prime of a is limit as x approaches a of f of x minus f of a all over x minus a. This expression should look familiar. It is the difference quotient, but now we're taking the limit as x approaches a. This limit gives us the slope of a tangent line at x equals a. We can also write the derivative in another equivalent form. Instead of using x, we can use h. Then the definition becomes limit as h approaches 0 of f of a plus h minus f of a all over h. Here, h represents a small change in x. As h approaches 0, the 2 points on the graph move closer and closer together. When we take the limit, we get the exact slope of the curve at that point. So, the derivative represents several important ideas. First, it represents the slope of the tangent line to the graph. Second, in many applications, the derivative represents instantaneous velocity. Third, more general, the derivative represents the instantaneous rate of change of a function. So, whenever we want to know how something is changing at a specific point, we use the derivative. Now, let's practice using the definition of the derivative. We're given the function f of x equals 3x squared minus 4x plus 1, and we want to find f prime of 2. That means we want to find the derivative of the function f when x equals 2. We can use the definition f prime of a equals limit as h approaches 0 of f of a plus h minus f of a all over h. Since we want f prime of 2, we'll let a equals 2. F prime of 2 equals limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. I will compute f of 2 plus h and f of 2 on the side and then plug it back into this formula. To find f of 2 plus h, we substitute 2 plus h into the function. We'll have 3 times 2 plus h squared minus 4 times 2 plus h plus 1. Two plus h squared is 4 plus 4h plus h squared. Negative 4 times 2 plus h is negative 8 minus 4h plus 1. 3 times 4 plus 4h plus h squared is 12 plus 12h plus 3h squared. Minus 8 minus 4h plus 1. Then now we'll combine like terms. 12h minus 4h is 8h. 12 minus 8 plus 1 is 5. F of 2 plus h equals 3h squared plus 8h plus 5, and I substitute it into the formula. Now, I need to find f of 2. To find f of 2, I substitute 2 into the function. I'll have 3 times 2 squared minus 4 times 2 plus 1. 2 squared is 4, and 4 times 3 is 12. 4 times 2 is 8, and plus 1. 12 minus 8 plus 1 is 5. F of 2 equals 5. I will substitute f of 2 with 5. All over h. In the numerator, we combine like terms. Since 5 minus 5 equals 0, we are left with 3h squared plus 8h in the numerator. All over h. In the numerator, I'll factor out h. Now we have h times 3h plus 8 over h. The h in the numerator and the h in the denominator cancel out, leaving us with 3h plus 8. We have the limit as h approaches 0 of 3h plus 8. We substitute 0 for h. This gives 3 times 0 plus 8. 3 times 0 is 0, plus 8 is 8. So f prime of 2 equals 8. That means the derivative of f of x at x equals 2 is 8. That also means the slope of the tangent line to the curve at x equals 2 is 8. This example shows how we can use the limit definition of the derivative to find the slope of a curve at a specific point.